Hello, good afternoon one and all. Today we will going to discuss about the node and loop analysis and related to its example. Here we have to find out the background of the KCL and KVL in the node analysis. In the node analysis there is a dependent source and related to its problem, and independent source and related its problem, as well as dependent source and related to its problem. Loop, that is the mesh analysis, independent source relating to its problem, and dependent source and related to its problem practice problem and its solution. See, first we will see that there is a KCL and KVL rule. In the Kirchhoff's current law, just the rule told that the algebraic sum of the electric current and that merge in the common node, the circuit is a zero. That is the summation of the input current, which is equal to the summation of the output current. And the Kirchhoff's voltage law, the sum of the voltages around the closed loop circuit is equal to zero. That is the summation of Vk, which is equal to 0. That is the voltage source is starting from K, which is equal to 1 to N, that is Vk, which is equal to 0. Then the KCL and KVL example. In this example, we have to find out the total current and the voltage drop across the node B and D. From this figure, the 6 volt is provided, the resistance 80 kilo ohm in series with the 12 volt voltage source, and the current is flowing through the circuit I, which is I, and load resistance is the 40 kilo ohm. Using the Ohm's law told that the voltage drop across the any resistance which is equal to current flowing through the resistance with respect to its resistance. So we can find out here the I, which is equal to the total voltage upon the total resistance, and the total voltage is calculated 6 minus 12, which is equal to minus 6 volt. Then taking I going out for the source, and which is taken as the positive. Therefore the total resistance we have to be calculated, that is the 80 kilo ohm plus 40 kilo ohm. 80 kilo ohm plus 40 kilo ohm, which is equal to 120 kilo ohm. Then current flowing through the circuit I, which is equal to V upon R. V is provided minus 6 volt, and its total resistance, that is the 80 plus 40, which is equal to 120 kilo ohm, which is equal to minus 0.05 milliampere. Now using the Kirchhoff's voltage law to the loop, the voltage drop across the BD, which is equal to 6 plus VR1. 6 plus VR1, which is equal to 80 kilo ohm into the current flowing through the circuit is a 0.05 milliampere. Therefore 80 into 10 raised to 3 into 0.05 into 10 raised to minus 3. Therefore 6 plus 4, which is equal to 10 volt. Means whatever the question is asked for this example, to find out the total current is the minus 0.05 milliampere, and the total voltage drop across the BD, that is the VBD, which is equal to 10 volt. Then for this example, the nodal analysis. In case of the nodal analysis of the electronic circuit is based on the assigning the nodal voltages at various nodes of the circuit with respect to the reference, and then finding the nodal voltage to analyze the circuit. The simple representation of the nodal voltage is as shown in figure below. As shown in figure, a node is a point in the circuit where two or more wires meet, and at these nodes one can assign the nodal voltage with respect to the reference to the ground. From this circuitry, the voltage V is able to applied across the R and R, means voltage should be same, voltage drop across the same if the resistance value is the same, and the node voltages at a node 1, 2 and 3, there is a V1, V2 and V3 respectively. Then in the node analysis in consideration, the nodal analysis in consideration for the independent sources, means first we can find out the number of the Kirchhoff's current law equations, and these are used to find the node voltage, that is the number of the nodes, which is equal to the number of the equations minus 1. then we can write the Kirchhoff's current law equation for the nodes and to solve them to find with respect to the nodal voltages. Once we have find out these nodal voltages, then supernode analysis. Supernode analysis is generally used for independent voltage source. The more than two nodes should be required. From this figure, we have to find out the node voltage V1 and V2 respectively. By observing this circuit, there are two current source should be given. First current source, its value is the 1 milliampere, and another current source, its value is the 4 milliampere. Then there are the two nodes. First node is the V1 and V2. These are the two nodes, and our intention to find out the node voltages V1 and V2 respectively. Then basically here 1, 2 and 3, there are the 3 loops should be given. 3 loops should be given, means the number of the loops is the n minus 1, which is equal to number of the loop is 3, 3 minus 1 means 2. There are the two equations we have to be find and to solve for the node voltages V1 and V2 respectively. Then using the Kirchhoff's current law, in this example we write the Kirchhoff's current law equation at the node as shown in figure and solve them to find out for the respective node voltages. Then assume the current entering out of the node is taken as a positive, and current leaving from the junction is taken as the negative, or vice versa. If you consider the current entering into the junction is a positive and current leaving from the junction is a negative, then you keep as it is throughout the process. Then with reference to the figure, we write now the equation 1 minus 1 milliampere plus V1 upon 12 kilo ohm plus V1 minus V2 upon 6 kilo ohm, which is equal to 0. Means from this equation, this is the equation number 1. Then in the second loop, we find out the 4 milliampere plus V2 minus V1 upon 6 kilo ohm plus V2 upon 6 kilo ohm, which is equal to 0. This is the equation number 2. Means from equation 1 and equation 2, these two are the KCL equations, and solving for V1 and V2 respectively. Therefore minus 12 here, first we have to find out this equation. The sub equation we have find out its numerator keeping as it is the same value. Hence here we multiply by 12. There is a 12 milliampere and here is a kilo ohm. Both are cancelled. Hence here is the minus 12 plus V1 plus here 2V1 minus 2V2 upon 12k. 12k is a multiply by 0. Then whole answer should become to the 0. Hence the equation is minus 12 plus V1 plus 2V1 minus 2V2, which is equal to 0. So by here 2V1 plus V1 is the 3V1 minus 2V2, which is equal to 12. This is the sub equation number 118. Then similarly here we multiply by 6 of this term. There is a 6 into 4, 24, and here is the milliampere and kilo ohm. This value gets cancelled. Hence here is the 24 plus here 2V2. Here is the 2V2 minus 2V1 minus 2V1. 2V2. Here is the V2 minus V1 plus V2. There is a 2V2 and minus V1 should become, and whatever the denominator common part is multiplied by 0, it is again come to the 0. Then equate the equation 1a and 2a. For V1 which is equal to, here is the V1 which is equal to 24 plus 2V2. 24 plus 2V2. Is from this equation we find out, see this equation, this equation. There is a 2V2 means here is the V1 which is equal to 24 plus 2V2 minus V1 which is equal to 0. Then this minus V1 is a transfer from LHS to the RHS. Hence it is the V1 which is equal to 24 plus 2V2 and 3V1 minus 2V2 which is equal to 12. Whatever the value of this V1 is keep in the equation number 1a, equation number 1a. Therefore 3V1, V1 which is equal to 24 plus 2V2, then 24 into 3 plus 6V2 minus 2V2 which is equal to 12. Means here we have to be calculated. Just go through the calculator and we verify the result. There is a 4V2 which is equal to minus 60. V2 is equal to 60 divided by 4. Means here is the 60 divided by 4 which is equal to 15. Therefore V2 which is equal to minus 15 volt. Then we substitute the value of this V2 in this equation. V1 which is equal to 24 minus 2V2 means minus 30. Therefore 24 minus 30 which is equal to minus 6 volt. In this way we have to be calculated the value node voltages of the given circuit V1 and V2 is calculated. Then next equation. For this example there are the independent voltage sources given. There are the two voltage sources provided here, that is the 6 volt and 3 volt respectively. And to find out the value of the V1, then here is there are the two loops, means n minus 1 is 2 minus 1, only there is a one equation should be formed. Therefore V1 minus 6, here is the V1 minus 6 upon 6 kilo ohm plus V1 upon V1 minus 0 upon 3 kilo ohm plus V1 upon 3 kilo ohm plus V1 minus 3 upon 6 kilo ohm which is equal to 0. Then again we have here denominator should be same. Then what we do here, 2 is a multiply by this equation. Therefore V1 minus 6 upon 6 plus here 2V1 upon 6 kilo ohm plus V1 minus 3 which is equal to 0. Then this 6 kilo ohm again multiply by 0, then again its term should be 0. Therefore V1 minus 6 plus 2V1 plus V1 minus 3 which is equal to 0. Therefore 2V1 plus V1 3V1 plus V1 4V1. Therefore 4V1 which is equal to 9. Therefore V1 which is equal to 9 upon 4V. Then I0 we have to be substitute the total current I0 which is equal to V1 upon 3 kilo ohm. Here the total current is able to flow through this circuit. Here there is a due to the 6 volt and due to the 3 volt the total current is flowing through this circuit. Hence what we do here, the I0 which is equal to V1 upon 3, then V1 is a 9 upon 4, 9 upon 4 V, and V is the 3 volt. Okay, 6 minus 3 means here is the 3 volt which is to be given, means 3. Here 9 upon 4, this 3, 9 divided by 3 means 3. Here 3 gets cancelled, 3 upon 4. This will become for the 3 upon 4, means V1 which is equal to 9 upon 4. V1 is the 9, therefore 3 upon 4 milliampere current is coming here. Means for this example we have to find out the value of the V1. Then for this circuitry, find the V0 for the nodal analysis. For this circuit we need to overlook and the node with the dependent source and to form the equation around it. Then we use the KCL at node 1 and 2 and to derive the equation based on the current flow. At node 1, taking the positive sign convention and to apply the KCL, therefore minus 2m plus Vx upon 3 kilo ohm plus V2 upon 6 kilo ohm plus V2 upon 12 kilo ohm which is equal to 0. This is the equation number 1. And at a node 2 there is a V2 upon 16 kilo ohm plus V2 upon 12 kilo ohm minus here minus 2 milliampere here is the 2 milliampere current is flow. Its opposite direction, hence it is the minus 2 milliampere plus Vx upon 3 kilo ohm, which is equal to 0. This is the equation number 2. Means from equation number 1 and from equation number 2, we get the controlling the equation at node 1. There is a 2m which is equal to Vx upon 6 kilo ohm plus Vx upon 3 kilo ohm. Then again we have to be controlling this equation where denominator should be same. Therefore we multiply the 2 for this parameter. Therefore 2m which is equal to Vx plus 2Vx upon 6 kilo ohm. Therefore 12 which is equal to Vx plus 2Vx. There is a 3Vx and 3Vx which is equal to 12. Therefore 12 divided by 3 which is equal to 4. Therefore Vx which is equal to 4 volt we have calculated. Now put this equation Vx which is equal to 4 in the equation number 2 from this equation number 2. Then V2 upon 12 kilo ohm plus V2 upon 12 kilo ohm minus 2 milliampere plus 4 upon 3 kilo ohm which is equal to 0. Then what we do here, again here denominator should be same. Therefore V2 upon 12 kilo ohm plus V2 upon 12 kilo ohm, there minus 2 milliampere plus here 4 into 2 8 upon again which is equal to 0. Therefore V2 which is equal to 4 volt. V2 which is equal to 4 volt is how, because here V2 plus V2 upon 12k, 2V2 upon 12k, V2 upon 6 kilo ohm minus 2m plus 4 upon 3 kilo ohm, hence here multiply by 2. Hence the equation is V2 minus 12. Here is the minus 2 into 6, 12 plus 8 which is equal to 0. Therefore V2 which is equal to here 12 minus 8 which is equal to 4 volt. Hence as V0 which is equal to V2 which is equal to 4 volt. Means in this way we have to be controlling the equation. From this lecture we have to be understand how to resolve to background for the KCL, KVL, its nodal analysis, dependent independent sources, mesh analysis, and practice problem and its solution. Thank you.